Okay, so in this particular video, we're going to see how to sketch a graph of a hyperbola, and very quickly sketch it. You can plug these things now into your computers and your smartphones and etc. and get the formula very fast. But here we're going to go ahead and graph this hyperbola. We're going to find the center, vertices, foci, eccentricity, and the equation of the asymptotes. And this is kind of a cookbooky way to do it, not necessarily giving a lot of room for understanding. So let's say your equation looks like this here for a hyperbola. And so you got x minus h squared over a squared minus y minus k squared over b squared equals 1. Again, the only difference between this and an ellipse is this minus sign here. So I've given you, the first thing we know is the center is hk. So I'm going to draw kind of a graph of what this looks like. So here's your x and y axis, x and y. And the first thing we do to sketch a hyperbola by hand is to build the scaffolding. And I'm going to do that in blue. So this is your center, or h comma k. Okay, then since the a is under the x, we're going to go right and left a. So if you think about it, we're going to go right a, so we're going to take the square root of that number, and we're going to go left a and make a point. Then for b squared, that's under the y here, so we're going to go up and down b. So there's up b, there's down b, kind of whatever that length is. Right now it's we don't care. And then what we're going to do is make a box. So these are, I guess, not the vertices of your box, but you go ahead and create your box. Now if you had an xy in your equation somewhere, that would mean we would rotate that. So that's imagine that box rotating however many degrees. So if it's just one xy, it's going to rotate 45 degrees. So here we'll keep going. So and I have vertex of the box. So these are just points on the side of your box. I like to call this the scaffolding. That's probably improper, but that's really what we're doing, is we're making the scaffolding in order to create our asymptotes. And so those points, these 4 points, are the sides, actually the midpoints of every side of the box, if you wanted to be very precise about it. Okay, then we do the asymptotes by connecting the diagonals of our box or our rectangle and the center. And so there we have it for our asymptotes. Now to find the equation, I have that listed here. So this equation, think about this. So if this was the point on our line and we wanted this equation right here, that means we rose A, so rose here to A, and then we ran to B, ran a B length. So we would have, for this equation on the left, and it's positive, y minus k equals positive b over a, because we rose b and ran a, x minus h. So that's the equation for that asymptote. For this asymptote, the equation is the same, but it's a negative slope. So y minus k equals negative b over a for your slope, and then x minus h. And so that's your 2 equations for the asymptotes. The last thing is to find your vertices and how this thing opens. So I'll do that in green. Since the x comes first, and it's positive, not necessarily that it comes first, but that this is a positive out in front, we know this hyperbola opens left and right. So here's that vertice, or not vertice, that midpoint, or the middle of the side of the box. It's going to start there and open left and right. It's going to be basically the vertex of your hyperbola. Alright, so we've got our hyperbola sketched in green there. So we did all that other stuff just to kind of get a general idea of where the asymptotes are. And now we know. So the last thing is to find the foci. and here's the foci equation. C equals a squared plus b squared. So there it is. And so here would be how you'd find those two. And it's not as hard as it looks. Notice C equals the square root of a squared plus b squared. That should be a squared. I messed that up. You'd use the actual number on the bottom once it's set equal to 1. And you go up here, and so if you did that, I'm kind of running out of colors, so I'll use black. And you started here at the center and counted to the left a negative C. There's one foci. And then to the right a positive C. That would be the other foci. But there's the equation right here for finding both of those. And then the last thing is eccentricity. Eccentricity is the A value divided by C. And it should be greater than 1 for a hyperbola. Okay, so let's take a look at this. I was going to give you the equation for if it goes the other way, but I'm going to run out of time. So let's take a look at this and go from the start to the end. So here's a general equation of a hyperbola. And the reason I know it's a hyperbola is we've got x squared minus y squared. So what we do in this case is 4x squared minus 25y squared. Let's get our x's together because we're going to have to complete the square. So we got 4x squared plus 16x and minus 25y squared plus 50y. And I'm going to add 109 to the right. So plus 109 on the right side of the equation. So if you be a good idea to, this is a good example, hit pause and see if you can get this thing to work out. So first off, when you complete the square, you can't have an a value in the quadratic. So we're going to take the 4 out. And so we'd have x squared plus 4x, because we factored out a 4. And then we're going to factor out a negative 25 with y squared. So you'd have y squared plus 2y. And it equals 109. So when you complete the square, you divide your middle term by 2 and square it. So there's my middle term, that's a 4. 4 divided by 2 is 2. 2 squared is again 4. So I'm going to add 4 to this side. However, we factored out of 4 of this parenthesis originally, so really we added a 16 because 4 times 4 is 16. So we're going to add a 16 to the right. Then we'll do the same with the 2. So middle term is 2. You divide it by 2 and square it. 2 divided by 2 is 1. 1 squared is 1. So you'd add 1 here. But on the left, we factored out a negative 25. So you're going to, if you would distribute that back through, that means we have a negative 25 we have to add to the right side in order for the equation to balance out. And so now we're ready to kind of simplify this thing. So you would have 4, and then this factors to x plus 2 squared minus 25. That factors to y plus 1 squared. And it equals to, so this would be equal to, you add all this stuff up, and I'm pretty sure I'm right, you get a 100. So then the final step is you want it to equal 1. So I'm going to divide by 100 on all sides here. I'll divide everything by 100. And reduce that. Well, 4 100ths is 1 25th. And so x plus 2 squared over 25 minus y plus 1 squared over 4 equals 1. So we're ready to graph this thing. So when you graph this, your center is negative 2, negative 1. And so I go left 2, up 1, or down 1. Whew. And so there's my center. That's we don't want to use black. Your A is 25, or square root of 25, which is 5. So, to find A, you take the square root of 25. And so you're going to go right and left 5 since it's under the x. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then your B is going to equal the square root of 4. And so you go up and down 2, 1, 2, 1, 2, and that is the midpoints of the sides of your rectangle in order to graph it. So again, that's the scaffolding. We're building this scaffolding to put in our asymptotes. So now you go ahead and connect the vertices of that rectangle, and that's the asymptote of our hyperbola. And so when you do this, then, since x leads, I know my hyperbola opens, right here's my vertex, and it opens right, and it opens left. Okay, so only a couple things left to find, and that's our foci, which would be, oh, and we need the equations of those. It always, you know, if you're taking this as a college algebra course, of course we got to have the equation of this line. And so what we would have on the left side is, you remember it was y, you know, if you wrote it down, y minus k, so y plus 1, because that's y minus k, equals, your rise is 2, and I would just rather get it from the graph, and your run is 5, so 2/5 x minus h, which would be x plus 2. And then you could simplify that by solving for y, but my video is kind of running too long, so we'll just call that good. And then this side would be similar. It would be y plus 1, but the only difference is the slope is negative, and then x plus 2. And, you know, again, add the 1 over, distribute the negative 2/5 through, and you get the y equals mx plus b form for both of those. Then your last step is to find your foci, and that's just taking the square. You find c, which is the square root of 25 plus 4. So c is equal to the square root of 29. So c in this case is about equal to 5.4. So from your center, you'd go right 1, 2, 3, 4, 5.4, which would be right in that vicinity, and left 5.4, which would be right in that vicinity. And so exactly this point would be negative 2 plus the square root of 29, comma, negative 1, and negative 2 minus the square root of 29, comma, negative 1. And then the last thing is to find the eccentricity. So eccentricity, in our case, is A over C. So you'd have the square root of 29. Let's make sure that's right. And so there's my mistake. I realize now, after looking at it, I'm like, that doesn't make sense. So your eccentricity in my formula was wrong. So I'll put a little note there. But its eccentricity is equal to C over A. Because you got to have a number bigger than 1 for hyperbola. If it's less than 1, it's an ellipse. And so E, in this case, would be the square root of 29 divided by 5. And so you'd have about, what did I say that was, a 5.4 divided by 5. So, you know, 1 point something. And so that's, so eccentricity, 5.385 divided by 5 looks like 1.07, about. And so that gives you kind of a general idea and of how to do these. So I'm running out of time. There is one other type, and that's if the y is positive. These would open, you'd have your box, you'd still do your asymptotes, but this time it opens up and down. So it only changes the equations of your asymptotes. And so instead of, you know, here I've got A underneath y, so just get your rise and your run from your box. Here's your rise, here's your run. Your rise is with the y, so you'd have A over B if you change which one's A and which one's B. And so, you know, you'd have y minus k equals plus or minus A over B x minus h. for your asymptotes. That's a plus or minus.